Okay, so in this section, we're going to talk about graphing techniques. And so the first one is the vertical shift. So if you have a function that says y is equal to fx plus k or y equals fx minus k, for example, like x squared plus 1 or x squared minus 1, that means that if it's a plus 1, if the number is outside of that x squared or that function, then you go up. If the number is if it's a positive one, and if it's a negative one, then you go down. Okay, minus one. So positive one, go up, minus one, you go down. Okay. All right, so that's a vertical shift. Okay. The next portion here, pause it. Okay, so now if you have a horizontal shift, that means it goes left and right. So if the number is inside of that function, so this is a plus one or a minus one, okay, if the number is inside, then that means you're going to go left and right. And it's the opposite of what you think. So if it's a positive one, you actually go to the left. If it's a negative one, you actually go to the right. Okay? So again, this is what I mean by being outside if the number is outside or inside. So outside, like the plus one, minus one, then that's dealing with up and down. If the number is inside, right, like here in the radical, then you're dealing with the shifting. Okay. Okay. So now the next one are talking about vertically compressed, vertically stretched. So compressed, so if we have, say, y is equal to the absolute value of x, all right, if the number in front of the x is between 0 and 1, okay, so for example, half of x, what's going to do to the graph, it's going to squish it. It's going to flatten it or widen it. So in this case, y equals uh, 1 half of x is going to look something like this. Okay, so this will be y is equal to 1 half the absolute value of x. Okay, so again, if the number is between 0 and 1, okay, it's gonna make that graph flatten. If the number in front of the in front of that absolute value is now bigger than 1, then it's going to make the graph skinnier. Okay, so so in this case, again, we have y is equal to absolute value of x. So if we have y equals 2x, it's going to make it skinnier. So it's going to pull it towards the y-axis. So it's going to go this direction. Okay, so this is going to be y is equal to 2 times the absolute value of x. Okay, all right. So again, that's when a is bigger than 1. All right. Now, what happens in regards to um, if the number is now inside? Okay. So in this case, we had the absolute value of y, sorry, if we have y equals square root of x, if we have a number inside the radical, right? For example, 2, and that number is bigger than 1, now it's dealing with the horizontal compression. Okay. So it's basically going to mimic what it did with the vertical stretch. Okay. So the vertical stretch and the compression, they basically mimic each other. So in this case, instead of flatten it, it's going to again push it towards the y-axis. Okay. So that's what it's going to do. All right. And again, if that number is bigger than 1, and if it's inside the radical. Same thing for the horizontal stretch. If the number is between 0 and 1, right? For example, 1 half, now it's going to stretch it towards the x-axis. So going like this. Okay, so square root of 1 half x. Okay, so then again, the last thing we're going to talk about here in this section is reflection. So this one is in regards to the graphing, reflection over the x-axis and reflection over the y-axis. So again, if we have f of x equals square root of x, so that graph looks like this, right? If there's a negative in front of the radical, then we're going to reflect it over the x-axis, right? So it would look like that, okay? Now, if the negative is inside the radical, all right, then we reflect it over the y-axis. So again, original, it looks like this on top left. And so if it was y equals square root of negative x, then it would just reflect over the y-axis. Okay, so you might say, well, you can't take the square root of a negative. You're correct. However, if we plug in a negative number in there, so for example, if I plugged in -1, right? What is going to be the output there? Well, I already have a negative, so negative, and I put another negative in there, so -1. Okay. Well, those two negatives are going to become positive, so it'll be a +1. So the square root of +1 is just going to be 1, right? So it spits out a 1 there. Okay. So it does work as long as the values you're putting in there are negative. Okay. Which makes it the product of a positive. All right, so basically those are your the graphic techniques or the essentials of graphing that you need to know for this section. So let's do some examples. All right. Let me pause it here. All right, so as I mentioned, this next part, all we're doing is matching the appropriate uh, equation or function to the appropriate graph. Okay. So um, you know, a lot of times it's just a process of elimination, right? So for example, the first one, this is a parabola. So that means I need to pick something from column 1 or column 2. I wouldn't pick anything from column 3 or 4 because that deals with absolute value. Okay. So it has to be something in column 1 or column 2. All right. So in this case, oops, um, for the first one there, it has nothing to do with shifting, right? The graph, the parabola doesn't shift left or right. So that means automatically I get rid of E and F, right? Because that deals with shifting. If the number is inside the parentheses, that deals with shifting, okay? Um, and also, this one looks like it's going up. So that means it has to be between A and B, right? Because it's going up or down, but in this case it goes up. So it has to be between A and B. So it can't be I or J because it's just talking about stretching um, that function. So in this case, since it's upside down, it has to deal something with reflection. Okay. So the answer to the first one there should be B. Okay. All right, and I'm just going to focus on the parabolas right now. So let's go to the third one here. So again, this is another parabola on the third graph here. And so that means I'm not dealing anything with the absolute value. So, um, so in this case, it does deal with shifting, going left and right, right? Because originally the graph would be like that originally, right, in the middle. Now it moved to the left. Okay, so so in this case, then I have to deal with E has to be E or F, right? Because if the number's inside the parentheses, that means that's dealing with shifting left and right. And it didn't go up or down, so that means it can't be A or B. All right, and of course it's not I or J. Okay, so in this case, remember when it's dealing with shifting, it's always the opposite of what you think. So um, it went to the left 2, so you would think it would be -2, but actually in reality it's +2. Okay, so it's going to be a +2. So it's always the opposite of what you think. +2 actually goes to the left, -2 actually goes to the right. Okay, and of course this also is another reflection because um, we have a negative in the front. Okay, all right. So so in this case, the answer to this one is going to be F. Okay. Then the last parabola there, okay, it has nothing to do with up and down or going left and right? So that means where A and B are out and E and F are out because that has to do with those going up or down, left and right. So it has to be between I and J. Okay. The negative has to do with something with reflection. So this is not reflecting anything. It's not upside down or to the right or whatever. So that means it can't be J. So it has to be I, right? So it's just stretching that to a factor of 2. So the answer to that one is I, right? Okay, any questions so far? Okay. All right, so now let's deal with the absolute value. So again, so that means the first column and second column are out. So we're going to deal with the third and the fourth column. So let's look at the middle one here. So this one again is dealing with shifting. So shifting means the number is inside the absolute value. The number is inside the absolute value. So automatically C and D are out because the number is outside of the absolute value. Okay. And then these ones here, K and L are also out because that's dealing with stretching of that function. So the possible answers we have are either G and H. Okay, so G and H are a possible answer. If we have a negative, right? For H is negative means it's going to reflect over. Okay, it's going to reflect. So in this case, it's not doing that, right? It's just still up. If it was negative, it would have been going down. Okay, so it cannot be H. So in this case, our answer here would be G for that one. Okay, so this is G here. All right, now let's look at this one here in the bottom left. So this one now, again, it's nothing, it doesn't go, it's not going left or right or up and down, right? It doesn't shift from the origin. So automatically I get rid of the C, D, and G and H, right? Because that means the graph has moved outside of the origin, but in this case, that is not the case. So it has to be between K and M, right? So it does do some stretching, right? A factor of 2, but in this case, it has to be a negative, right? It's a sad absolute value. It's upside down, right? If it was a positive, then it would have been going, going up, facing up, okay? So in this case, um, it's not doing that. It's going down. So the answer to this one has to be L. And I'm just kind of going through the thinking process with this when I'm trying to learn, these graphing techniques. Okay. And then the last one here, it has to do with shifting. Okay. So, so that means if the number is on the outside, it goes up and down. So the C and D are out. And then this one, it just stays in the origin. So those guys are out. So that means then it has to be between G and H. Okay. And it is negative, right? Because it's upside down, right? It's sad. So, and then it did shift to the left. So remember, if it's a positive 2, it actually goes to the left. If it's a negative 2 inside, it goes to the right. So the answer to this one has to be H. Okay, so it says write the function whose graph is the graph of y equals x to the third. All right, so remember x to the third, um, it looks something like this, right? It looks like an S or like being stretched out. Okay, so that's x to the third power. So we want to shift to the right 4 units, so that means we want to go to the right. So remember that deals with the parentheses, and it's always the opposite of what you think. All right, so we would think, all right, we would go add 4, but actually it's going to subtract 4. Okay, so this would be y is equal to x minus 4 raised to the third power. Okay, so that's what they want for shifting to the right 4 units. Okay, and then we go back to the drawing board. We're going back to the y equals x to the third. Now we want to shift it up 4 units. So that means the number is going to be outside of the parentheses. Okay, so it's no longer in the parentheses. So it's going to be going up and down. So it's going to be x to the third plus 4. Okay, so again, if the number is outside the parentheses, it's dealing with the up and down shifting. All right. Reflect over about the y-axis. So that means the negative is going to be inside, right? If it was reflecting over the x-axis, the negative would be the outside of the parentheses. So in this case, we'll have y is equal to, and I have to put the negative inside the parentheses, raised to the third power, right? So that's reflecting over the y-axis. And the last one here is vertically stretched by a factor of 4. So that means we just multiply our function here by 4. So 4 times x to the third. And that's it. Okay, so this one says we want to find a function, right? Find a function that is finally graphed after each of the following transformation is applied to the graph, right? I know it's talking about graph, but we're not graphing this. We want to find a function. We want to find the equation. Find the equation, okay, after these transformation has been implemented, okay? All right, so we're starting with this one. Y is equal to square root of x. That is our original function. So now it wants us to shift up 2 units, right? So remember, if we're talking about shifting up and down, the number has to be outside of the radical, okay? Outside of the radical. So in this case, for the first step here for A, all right, this is part A, our first equation or function is going to be y is equal to square root of x plus 2. Okay, so again, I do not put the number inside the radical because that's dealing with horizontal shifting. Okay, all right, so that's our first step. Okay, step 1. Okay, step number 2, now it wants us to reflect about the x-axis. Okay, so again, reflecting about the x-axis deals with the negative in front of the function. Deals with the negative in front of the function. Now we have to be careful, all right, because we want to keep everything we have from the first step. We're not starting back to square one. We're going to keep whatever we have from step 1 and implement that in step 2. Okay, so now I want to show you in the handout there. Let's pause this for a second. Okay, so we want to reflect about the x-axis. So on the handout, see the negative is in front of the function. So you you put the negative in front of the whole thing, in front of the whole function. Okay, so be careful with that. So in this case then, all right, a lot of students would say, oh, this must be y is equal to negative square root of x plus 2. That is not correct, right? We have to put the negative in front of the whole thing. So we actually put it y is equal to negative, in parentheses, square root of x plus 2. So that's what it's saying. We multiply the negative to the whole function. Okay? And then the last part here, part 3, is reflect about the y-axis. So now, again, it's dealing with that negative again, but in this case, that negative is going to go inside that x, okay, inside that radical. So let's go back to our graphing techniques, right? So we want to reflect about the y-axis, so you put the negative, replace the x by negative x. Okay, that's what it says. Replace the x by negative x. So that's what we're going to do. So that means then we'll have y is equal to negative, and then we'll replace the x just by negative x, because that's dealing with reflecting about the y-axis. Okay, then plus 2. All right. Okay, so then this is what they want. This is the transformations that they want, and then your final answer, should be this one right here. Okay. Okay, so again, we're going to start from scratch. So y equals square root of x. We're going to start back to the original. So the first one here wants us to reflect about the x-axis. So that means the negative is going to go in front of that function. Okay, so this would be y. So this is going to be step one. Right? So it'd be y is equal to negative square root of x. Okay, so that's the first step. Number two, now it wants us to shift up 2 units. So again, whatever we had originally, we need to use the previous step. So we still have the negative square root of x, but in this case, we need to what? We need to go up 2 units. So we're going to add a 2 there. Okay. And then the last step here is we want to shift to the left 3 units. So again, that's dealing with shifting left and right. So that means the number is going to be inside the radical. We keep everything we had before, but now we need to go shift left 3 units. All right, so we have y is equal to negative square root. I still got the +2 there. I have the x. So again, you have to be careful here because it says left 3 units. We will think, oh, that should go -3, but in fact, it goes +3. Okay, all right, and I'll tell you more about that, why that's the case in the next section. Okay, so in this case, we should put a +3 and not a -3. Okay, so this is what they want as our final answer. So this is what's saying after everything has been implemented, all the transformations have been applied, then what is your, what would the final function look like? Okay, all right. Hopefully that's what you got on your paper. All right, so the first one here again. I want to graph f of x equals x squared minus 1. I think about the parent function, the original function. So the original function is f of x is equal to x squared. Okay, so it's just a parabola at the center, right? It's at the origin, I should say. Okay, so now we have a -1, so that means it's going to go down 1. So here's the origins in the middle, so that just go down 1. All right, and again, I'm just doing a sketch. Doesn't have to be perfect, just a sketch, and I'm done. Okay, so this is going to be f of x is equal to x squared minus 1. I'm done. All right, so go ahead and try the next two, just going through that process. All right, so the next one here, we have g of x is equal to 2 times the square root of x minus 2 plus 1. So let's see. So again, what I want to do is, 1 second here. All right, so again, what I want to do is I want to write down what is my parent graph. What does the parent graph look like? So g of x will just be the square root of x, right? So, and then that would just be like somebody kicking a field goal. Okay. All right, so that's what the original or the parent function looks like. All right, so, and then you can, go through this process any way you like. All right, whatever makes sense to you. So I like to work on the outside and go in work inside. So I have a +1. So that means then my graph is going to go up 1, right? So I'll go up 1. Okay. And then I have, so again, it goes up 1. Then it goes, you have -2. So that means it's going to go not to the left 2, but it's going to go right 2. So it goes up 1, then right 2. And then I'm going to stretch it as a factor of 2. Okay, that's not a problem. So I start at the origin. So I'm going to go up 1 and then over 2. All right, so I'm right here. Okay. And then I'm going to stretch it by a factor of 2. So that means it's going to go stretch to towards the y-axis. All right. Something like that. Okay. And that's it. All right. So yeah, that's my thinking process. That's how I graph these things. But whatever works with your brain. Okay. All right. The next one here, we have f of x is equal to negative x plus 1 to the third minus 1. So again, our original function is going to be f of x is equal to x to the third, right? And again, this looks like a snake, like that, okay? All right, probably not the best drawing in the world. Try it one more time here. Okay. All right. So again, I'm going to focus on from the right outside in. So minus 1, that means I'm going to go down 1. Okay. And then plus 1 means I'm going to go to the right. I'm sorry, I'm going to go to the left 1. Okay. I almost fell into the trap. Go to the left 1. Okay. So down 1, left 1. And then I have a negative in the front. So that means it's going to reflect over the x-axis. All right. So let's worry about that last. So let's worry about the shifting first. So we go down 1. So again, I start at the origin, I go down 1, and then I go left 1, right? So here, this is where I'm at. Okay. And then if I were to graph it, right, I would have this graph here, but that's not what I want. I want to reflect, so that means if this is up, that means reflecting over the x-axis is going to come down, right? Reflecting is going to come down. So that means this part is going to go down like this. All right. And then this one here again, if this is down, that means I need to go up to reflect, right? It's reflecting, it's a mirror. So that means this part here is going to go this direction. Okay. And then that would be my answer there. Just a sketch.